Hi all, welcome back. So it's Sunday, it means we are back with our Leetcode problems again. Here is our next Leetcode problem, reverse integer. The description given a signed 32-bit integer x, return x with its digits reversed. If reversing x causes the value to go outside the signed 32-bit integer range, that is minus 2 power 31, 2 power 31 minus 1, then return 0. So we have to assume environment does not allow you to store 64-bit integers, signed or unsigned. So here is an example 1, 2, 3 that turns into 3 to 1, minus 1, 2, 3 which is minus 3 to 1. So 1 to 0. When you get 0, 0 is neglected and 2, 1 is reversed. And the main constraint is here, it should lie between the range of minus 2 power 31 to 2 power 31 minus 1. First of all, let us see how we are going to reverse the string. The logic behind this we are going to see. Let me explain you the logic. Let's consider our number. Hi all, welcome back. So it's Sunday, it means we are back with our Leetcode problems again. Here is our next Leetcode problem, reverse integer. The description given a signed 32-bit integer x, return x with its digits reversed. If reversing x causes the value to go outside the signed 32-bit integer range, that is minus 2 power 31, 2 power 31 minus 1, then return 0. So we have to assume environment does not allow you to store 64-bit integers, signed or unsigned. So here is an example 1, 2, 3 that turns into 3 to 1, minus 1, 2, 3 which is minus 3 to 1. So 1 to 0. When you get 0, 0 is neglected and 2, 1 is reversed. And the main constraint is here, it should lie between the range of minus 2 power 31 to 2 power 31 minus 1. First of all, let us see how we are going to reverse the string. The logic behind this we are going to see. Let me explain you the logic. Let's consider our number 1, 2, 3. The first example they have given only, let's consider. So first we need to separate each digit. So to separate each digit, let's take an, I'm going to like modulo divide the number with 10, so that I'll be getting, whenever we do modulo division, we'll be getting the reminder. So the reminder will be 3. Next, after doing this, now I need only 1, 2. So I need 1, 2 means I want to divide my number with 10, which gives me the quotient, that is 12. Later that 12 is again modulo divided with 10, which gives me 2. Later again my 12 is divided with 10, which gives me 1. However, I modulo divide again my number with 10, which again, modulo divide with 10, which again give me 1. So now these numbers, whatever the digits I have separated, 3, 2 and 1. So all these digits I need to take them in the same order, like my final reverse digit will be like 3, 2, 1. So how I am going to mix this 3 to 1? So here we use an other logic call. Let us take our first reverse bit as 0. Consider it as a 0. So now whenever I multiply, like my reverse bit is multiplied with 10 and then added to the digit I have separated. It means first it will go like 0 into 10 plus 3, which is equivalent to 3. And next, now my R is upgraded to 3, 0 to 3. So that now 3 into 10 plus my next digit was 2. So plus 2, which means 32. And later now my R is updated to 32, and this 32 into 10 plus my last digit was 1 plus 1, which is equivalent to 321. So in this way I'm going to do. So it is given that our integer shouldn't exceed the limit minus 2 power 31 to 2 power 31 minus 1. So that condition we are going to apply in our code, and how we are going to apply, let us see in the code. Now let's go back to our code. So here already we are having a method to reverse integer, that is a public int reverse int of x. So now let us take the input. To that I am taking, so integer is our input, right? So I am taking int data type int num is equivalent to math dot absolute value of x. So why I'm taking the absolute value? Because so I take all as a positive numbers as an input, and later I'll be applying the sign at the end of the code. And next I need a value to store all my digits which I am separating, right? So I am taking a d, and I am taking another variable, that is reverse number, to store the reverse number. I am initializing it with 0. So I have already discussed that in the logic, right, why we are taking it as 0. And now the condition comes here, while. It means while our num is not equivalent to 0 only, we can reverse our string, right? So whenever our number is not equivalent to 0, then first I am doing is, in my digit I have said, so how we are going to get the digit? We are going to modulo divide our number with 10, we get our digit. So that we are doing here. And now we are checking for this condition. What condition? So it should be a 32-bit integer range only. So for that I am checking here for the condition, if our reverse, so whatever the string we are reversing, it should be greater than integer dot max value dot max value minus d. Sorry, this is a small d, and then we are going to divide it by 10. Okay, then we are going to divide it by 10. So I'll tell you why we have did this. So this condition is used to check, is there any overflow of the integer. So the integer max value is 2 power 31 minus 1, right? So is it overflowing that value? To check for that, we are using this condition. So if it is not exceeding, then we are going to the next step. We are going to if it is exceeding, we are going to return 0. If it is not exceeding, then we are just coming out of the if statement, and we are going to that reverse number. We have a formula, right? The reverse value into 10 plus our digit, and then at last we have to divide our number by 10, so that the last digit of the number will be eliminated, and the remaining digits of the number will go again for the will go to this condition. It will be checked, and the process repeats. And finally I have to return the value, right? So here I am writing return if x is less than 0. If x is less than 0, if the condition is true, then I am going to return minus of r, or else I am going to, so this is a ternary operator. So what I am doing is, here we are having a negative number also, right? If my x is a negative number which is less than 0, it means I have given a negative number. So while I am returning, I need to return it with a minus symbol, that is signed with a signed note. Where if my x is greater than 0, then it means the statement is false, so I will be returning this value. So whenever the condition is true, the first value will be returned. Whenever the condition is false, the second value is returned. So instead of writing if else, we can use this ternary operator. So let us run whether any test cases have been failed. Let us check. Yeah, we have passed all the test cases, and now let us submit. If this passes, it means we have passed the hidden test cases too. Yes, this passed. Hope you all understood this. So I'll be coming up with the next problem on next week. So until then, please do like, share, comment, and don't forget to subscribe to my channel Chill with Bhumi. For more such content, please do subscribe and hit the bell icon. Ta-da!